On the morning of March 17, 1967, a Soviet air defense commander stationed at the Kubinka Air Base outside Moscow received urgent orders through his encrypted VHF radio network to scramble three interceptors toward an unidentified radar contact approaching the Soviet border from Finland. The transmission, encrypted using what Soviet engineers confidently described as an unbreakable rotating cipher system, traveled through multiple relay stations before reaching the pilot cockpits. The commander believed his words were secure, wrapped in layers of mathematical complexity that no foreign intelligence service could penetrate. He had been assured by the Ministry of Defense's Communications Security Directorate that NATO forces were blind to Soviet command frequencies, that their encryption protocols were impervious to Western decryption techniques, and that operational security remained absolute. Yet at that exact moment, 37,000 feet above the Baltic Sea, a United States Air Force RC-135 Rivet joint reconnaissance aircraft was recording every syllable of that transmission. The aircraft signals intelligence operators, seated in a cramped cabin filled with oscilloscopes, spectrum analyzers, and magnetic tape recorders, were not only capturing the encrypted radio signals but decrypting them in real time. Within minutes, the full text of the Soviet commander's orders, including the interceptor call signs, altitude assignments, and weapon arming instructions, was transmitted via secure data link to NATO headquarters in Brussels. By the time the Soviet MiG fighters reached their patrol altitude, American intelligence analysts had already plotted their flight paths, identified their tactical doctrine, and cataloged the communication protocols that governed their operations. The Soviet commander never knew that his voice, his orders, and his operational security had been completely compromised before his pilots even engaged their afterburners. Throughout the 1960s and well into the 1970s, Soviet military leadership operated under a strategic assumption that formed the backbone of Warsaw Pact operational doctrine. Their encrypted radio communications were secure. This confidence was not rooted in arrogance alone, but in decades of investment in signals intelligence countermeasures, cipher development, and communication infrastructure hardening. Soviet cryptographers had developed rotating frequency hopping systems, multi-layer encryption algorithms based on one-time pads, and secure burst transmission protocols designed specifically to resist Western interception. The Soviet General Staff published internal communications security manuals asserting that NATO forces lacked the technical sophistication to decode their operational traffic, and that even if Western forces could intercept transmissions, the encryption would render the intelligence useless. Soviet air defense commanders, tank battalion leaders, and naval fleet coordinators relied on this assurance every time they transmitted orders, believing their words traveled through an impenetrable electronic shield. The strategic implications of this confidence were profound. If Soviet commanders believed their communications were secure, they could coordinate large-scale military operations, issue nuclear strike authorizations, and direct battlefield maneuvers without fear of enemy foreknowledge. But this confidence was an illusion, and the United States Air Force had been systematically dismantling it since the early days of the Cold War. The Boeing RC-135 Rivet joint was not merely a reconnaissance aircraft. It was a flying signals intelligence fortress, a technological marvel specifically engineered to intercept, decode, and analyze enemy communications across the entire electromagnetic spectrum. Derived from the KC-135 Stratotanker airframe, the RC-135 was transformed through a classified modification program known as Big Safari into a platform capable of detecting radio transmissions from distances exceeding 300 miles. The aircraft's fuselage bristled with antennas, receivers, and direction-finding arrays that could isolate individual radio frequencies from a chaotic electromagnetic environment. Inside, the mission cabin was configured with specialized operator stations where Air Force signals intelligence specialists monitored Soviet communication networks, identified command frequencies, recorded encrypted transmissions, and coordinated with ground-based decryption facilities. The Rivet joint's operational range allowed it to fly extended missions along the borders of Soviet airspace, loitering for hours while its sensors swept across military radio bands. Its crews operated under strict rules of engagement that prohibited actual airspace violations, yet the aircraft's sophisticated receivers could penetrate deep into Soviet territory, capturing transmissions from command bunkers, mobile radar sites, and tactical aircraft operating hundreds of miles inside the Iron Curtain. Declassified National Security Agency reports from the period describe the RC-135 as the single most effective signals intelligence platform in the American arsenal, responsible for collecting more Soviet communication intelligence than all other sources combined. The technical capabilities of the RC-135 Rivet joint were revolutionary for their time, representing the cutting edge of electronic warfare and signals intelligence collection. The aircraft was equipped with multiple receiver systems operating simultaneously across VHF, UHF, and HF bands, allowing it to monitor everything from tactical ground-to-air communications to long-range strategic bomber coordination channels. Each receiver station was paired with direction-finding equipment that could triangulate the geographic origin of a transmission with extraordinary precision, enabling analysts to map Soviet command networks and identify the physical locations of transmitters. The Rivet joint's operators used spectrum analyzers to identify signal characteristics, modulation patterns, and encryption signatures, building electronic profiles of Soviet communication systems that could be matched against known encryption methods. Once a transmission was captured, it was recorded on magnetic tape and either analyzed on board by linguists and cryptanalysts or transmitted via secure data link to ground stations in West Germany, Turkey, or the United Kingdom for further decryption. The aircraft carried linguists fluent in Russian and other Warsaw Pact languages who could provide real-time translation of decrypted transmissions, giving American commanders immediate access to Soviet operational intentions. This combination of interception, decryption, and translation capabilities meant that the RC-135 could deliver actionable intelligence faster than Soviet commanders could issue follow-up orders, fundamentally altering the intelligence advantage in Cold War Europe. Soviet confidence in their communication security was rooted in a fundamental misunderstanding of American signals intelligence capabilities. Throughout the 1960s, Soviet communication security officers believed that their encryption systems, particularly those based on mechanical cipher devices and one-time pad protocols, were mathematically unbreakable. This belief was technically correct in a narrow sense. A properly implemented one-time pad cipher is theoretically immune to cryptanalysis. However, the practical implementation of these systems across thousands of Soviet military units, operating under combat conditions with varying levels of training and equipment maintenance, introduced vulnerabilities that American intelligence agencies exploited ruthlessly. Soviet radio operators, pressed for time during exercises and real operations, frequently violated encryption protocols by reusing cipher keys, transmitting longer messages than security guidelines permitted, or failing to properly synchronize their encryption devices. Each of these operational security failures created opportunities for American cryptanalysts to attack the ciphers using frequency analysis, pattern recognition, and known plaintext attacks. Additionally, the sheer volume of Soviet military communications created a statistical advantage for NSA analysts. Even if individual messages were difficult to decrypt, the aggregate patterns of communication traffic, transmission timing, and frequency usage revealed operational rhythms and command relationships that were themselves valuable intelligence. Declassified NSA documents from the 1970s describe how American cryptanalysts maintained extensive databases of Soviet communication patterns, allowing them to predict when major military exercises were being planned, when bomber squadrons were being alerted, and when missile units were changing readiness postures, all without decrypting a single message. The breakthrough that allowed the United States to decrypt Soviet military communications on a massive scale came not from a single technological innovation, but from a systematic, multi-decade effort to collect, analyze, and exploit weaknesses in Soviet communication security practices. Starting in the late 1950s, the National Security Agency established a dedicated program to target Warsaw Pact military communications, deploying linguists, cryptanalysts, and signals intelligence specialists to monitor Soviet radio traffic around the clock. Ground-based listening posts in West Berlin, Norway, Turkey, and Alaska captured Soviet transmissions and forwarded them to NSA headquarters at Fort Meade, Maryland, where teams of analysts worked to identify encryption methods, catalog cipher systems, and develop decryption techniques. The RC-135 Rivet joint aircraft extended this capability into the air, allowing the United States to intercept communications that were too distant or too fleeting for ground stations to capture. The combination of ground and airborne collection created a comprehensive surveillance network that left almost no Soviet transmission unmonitored. By the mid-1960s, NSA analysts had successfully reverse-engineered multiple Soviet cipher machines, identified recurring weaknesses in operational security procedures, and developed automated decryption systems that could process intercepted transmissions within minutes of capture. These systems were not infallible. Some Soviet communications, particularly those using properly implemented one-time pads, remained secure, but the percentage of intercepted traffic that could be decrypted was high enough to provide NATO commanders with a comprehensive picture of Soviet military activity across the entire Warsaw Pact theater of operations. The strategic impact of this signals intelligence dominance was staggering. Every time a Soviet air defense commander issued orders to intercept a NATO reconnaissance flight, American intelligence officers knew the exact location of the interceptors, their fuel state, their weapon load, and the rules of engagement they were operating under. When Soviet tank divisions conducted training exercises in East Germany or Poland, NATO intelligence could reconstruct the entire order of battle, identify unit commanders by voice, and predict tactical movements based on intercepted radio traffic. During periods of heightened tension, such as the 1968 invasion of Czechoslovakia or the 1973 Arab-Israeli War, American signals intelligence provided warning of Soviet military preparations days or even weeks in advance, allowing Western governments to adjust their own military postures accordingly. Declassified. Air Force mission reports describe instances where RC-135 aircraft intercepted Soviet bomber launch orders during strategic exercises, providing NATO commanders with advance notice of simulated nuclear strike missions that Soviet planners believed were being conducted in complete secrecy. This intelligence advantage extended beyond tactical military operations to encompass strategic nuclear command and control. American analysts could monitor the readiness status of Soviet intercontinental ballistic missile units, track the movements of ballistic missile submarines through communication intercepts, and detect changes in nuclear alert postures that indicated escalating tensions. The United States, in effect, had a real-time window into Soviet military decision-making at almost every level of command, a strategic advantage that Soviet leadership did not fully comprehend until it was far too late. The Soviet realization that their communications were compromised came gradually and painfully. Throughout the late 1960s, Soviet military intelligence analysts began noticing troubling patterns. NATO forces seemed to anticipate Soviet military exercises with uncanny accuracy. Western reconnaissance flights appeared to know exactly when and where Soviet interceptors would be scrambled, and NATO electronic warfare units demonstrated a detailed understanding of Soviet radar and communication frequencies that should have been classified. Initially, these observations were attributed to espionage, and Soviet counterintelligence services launched extensive mole hunts within their own ranks, searching for human penetrations that could explain the intelligence leakage. However, by the early 1970s, it became increasingly clear that the problem was not isolated spies, but a systemic compromise of Soviet communication security. Declassified Soviet Ministry of Defense reports from the post-Cold War period reveal internal assessments, admitting that American signals intelligence capabilities had rendered Soviet operational security critically degraded, and that NATO forces possessed comprehensive awareness of Warsaw Pact communication networks. One particularly damning Soviet intelligence analysis from 1974, later declassified after the collapse of the USSR, concluded that signals intelligence aircraft had been successfully intercepting and decrypting Soviet military communications for at least a decade, and that operational security in the radioelectronic domain must be considered fully compromised. This admission forced a complete reevaluation of Soviet communication doctrine, leading to a crash program to develop more secure communication systems, stricter encryption protocols, and alternative command and control methods that relied less on radio transmissions. The Soviet response to this intelligence catastrophe was both immediate and inadequate. Starting in the mid-1970s, the Soviet military began deploying new generations of encrypted communication systems, including the R-123 and R-173 tactical radios, that incorporated more sophisticated encryption algorithms and frequency-hopping capabilities designed to resist Western interception. Soviet communication security officers imposed stricter operational protocols, requiring more frequent changes of cipher keys, shorter transmission times, and mandatory use of code words for sensitive information. The Soviet General Staff issued directives limiting the use of radio communications during peacetime and ordering units to rely on landline communications whenever possible. However, these measures were undermined by the practical realities of commanding a massive, geographically dispersed military force. Modern combined arms warfare required rapid, flexible communication across vast distances, and any attempt to restrict radio usage hampered operational effectiveness. Moreover, the new Soviet encryption systems, while more secure than their predecessors, were not invulnerable. American signals intelligence agencies adapted quickly, developing new interception and decryption techniques that maintained at least partial access to Soviet communications. Declassified NATO intelligence assessments from the 1980s indicate that while Soviet communication security did improve marginally, NATO forces retained significant signals intelligence advantages throughout the remainder of the Cold War, and Soviet commanders continued to operate under the assumption that at least some of their communications were being monitored by Western intelligence. The role of the RC-135 Rivet joint in this intelligence war cannot be overstated. Between 1965 and 1985, these aircraft flew thousands of missions along the Soviet periphery, from the Arctic Circle to the Mediterranean, collecting signals intelligence that shaped NATO strategy and informed Western understanding of Soviet military capabilities. The crews who flew these missions operated under conditions of considerable risk. Soviet fighters regularly intercepted RC-135 aircraft, and there were multiple incidents where Soviet pilots attempted aggressive maneuvers designed to intimidate or force down American reconnaissance flights. Despite these dangers, the intelligence value of Rivet joint missions was considered so critical that operations continued without interruption throughout the Cold War. Declassified mission logs describe flights lasting more than 12 hours, with crews monitoring Soviet communication networks during major military exercises, capturing launch orders during ballistic missile tests, and tracking the movements of Soviet naval forces through intercepted fleet communications. The intelligence collected by these missions was disseminated to the highest levels of the U.S. government, briefed to presidents, and used to inform strategic arms control negotiations, military budget decisions, and contingency planning for potential conflicts with the Soviet Union. By the early 1980s, the cumulative weight of American signals intelligence superiority had forced a fundamental restructuring of Soviet military communication doctrine. The Soviet Ministry of Defense issued new regulations requiring all sensitive operational communications to be transmitted via secure landline networks whenever possible, mandating the use of courier services for critical orders, and establishing strict penalties for communication security violations. Soviet military academies began teaching defensive signals intelligence techniques, training officers to assume that all radio transmissions were being monitored and to structure their communications accordingly. The Soviet General Staff initiated a massive program to harden communication infrastructure, burying cables, shielding transmission facilities, and deploying mobile communication units that could relocate frequently to avoid detection. These measures represented an implicit admission of defeat in the electronic warfare domain. The Soviet Union, once confident in the security of its communications, had been forced to fundamentally alter its command and control architecture because American intelligence agencies had proven capable of intercepting and decrypting its most sensitive military transmissions. The strategic implications extended beyond military operations to encompass broader Cold War dynamics. If Soviet commanders could not trust their own communications, they faced a persistent disadvantage in any crisis or conflict, unable to coordinate military actions without risking that their plans would be known to NATO forces before they were executed. The legacy of the RC-135 Rivet joint's Cold War operations continues to shape modern signals intelligence practices. The lessons learned from decades of intercepting Soviet communications established the doctrinal foundation for contemporary electronic warfare and signals intelligence, demonstrating that even heavily encrypted communications can be compromised through patient, systematic exploitation of operational security weaknesses. The technological innovations developed for the Rivet Joint program, including advanced receiver systems, automated signal processing, and real-time decryption capabilities, formed the basis for subsequent generations of signals intelligence platforms. Modern RC-135 aircraft, significantly upgraded with digital receivers, satellite communication links, and advanced cryptanalytic processors, continue to fly missions around the world, intercepting communications from adversaries who, like their Soviet predecessors, believe their transmissions are secure. The strategic principle established during the Cold War remains valid. In modern warfare, the side that controls the electromagnetic spectrum, that can intercept and decrypt enemy communications while protecting its own, possesses a decisive advantage that can determine the outcome of conflicts before the first shot is fired. The Soviet commanders who confidently issued orders over encrypted radio networks in the 1960s and 1970s, believing their words were secure, never imagined that American intelligence analysts were listening to every transmission, building comprehensive maps of Soviet command structures, and providing NATO commanders with a transparency into Warsaw Pact operations that fundamentally altered the strategic balance of the Cold War. The RC-135 Rivet joint proved that no communication is truly secure if an adversary possesses the technical sophistication, the operational persistence, and the analytical capability to systematically exploit vulnerabilities. And that lesson remains as relevant today as it was during the darkest years of the Cold War confrontation between East and West. The technical architecture that enabled the RC-135 Rivet joint to achieve such comprehensive signals intelligence dominance was the product of decades of engineering innovation, operational experience, and intelligence collaboration between the United States Air Force, the National Security Agency, and defense contractors specializing in electronic warfare systems. The aircraft's signal collection capabilities were organized around multiple integrated receiver systems, each optimized for specific frequency ranges and signal types. The primary VHF-UHF receivers could monitor dozens of channels simultaneously, automatically scanning across frequency bands to detect active transmissions and isolate signals of interest from background noise. These receivers were connected to highly directional antennas mounted along the aircraft's fuselage, wingtips, and tail section, allowing operators to determine the precise bearing of detected transmissions through triangulation. Once a signal was detected and its direction established, the aircraft's communication intelligence specialists could focus additional receivers on that frequency, capturing the full transmission for recording and analysis. The sophistication of this system lay not just in its ability to intercept signals, but in its capacity to process vast quantities of electromagnetic data in real time, sorting relevant military communications from commercial radio traffic, civilian aviation channels, and electronic noise generated by radar systems and other emitters. The human element of RC-135 operations was equally critical to the mission's success. Each Rivet joint aircraft carried a specialized crew of signals intelligence operators, linguists, and cryptanalysts who worked in coordinated teams to identify, intercept, decrypt, and translate Soviet communications during missions that could extend beyond 15 hours. These specialists underwent months of intensive training at Air Force intelligence schools and NSA facilities, learning to recognize Soviet communication protocols, identify specific Soviet military units by their transmission characteristics, and operate complex interception equipment under operational conditions. Russian-language linguists assigned to RC-135 crews were required to demonstrate fluency not only in standard Russian, but also in military terminology, tactical jargon, and the regional accents and dialects spoken by Soviet military personnel from different parts of the USSR. Cryptanalysts aboard the aircraft were trained in the specific encryption systems used by Warsaw Pact forces, equipped with reference materials detailing known Soviet cipher machines, and connected via secure data links to ground-based decryption centers, where NSA analysts could provide real-time support during particularly challenging decryption efforts. The combination of technical collection capabilities and highly trained human analysts created a signals intelligence system that could rapidly transform raw intercepted radio signals into actionable intelligence that NATO commanders could use to make strategic and tactical decisions. The operational tempo of RC-135 missions during the Cold War reflected the strategic priority that American military leadership placed on signals intelligence collection against Soviet forces. Declassified Air Force historical records indicate that between 1965 and 1985, RC-135 aircraft flew an average of 50 to 60 reconnaissance missions per month along the Soviet periphery, with individual aircraft and crews deploying to forward operating bases in Europe, Asia, and the Middle East for extended periods. These missions followed carefully planned flight routes designed to maximize collection opportunities while remaining in international airspace, flying parallel to Soviet borders at distances that kept the aircraft legally outside Soviet territorial limits, but close enough for their sensitive receivers to intercept transmissions from deep inside Soviet territory. Mission planning required close coordination between Air Force intelligence officers, NSA analysts, and NATO intelligence commands, who identified priority intelligence requirements based on current geopolitical tensions, planned Soviet military exercises, and gaps in existing intelligence coverage. The most sensitive missions were flown during periods of heightened Cold War tensions, when American intelligence agencies needed to monitor Soviet military readiness and detect potential preparations for military action. During the 1968 Soviet invasion of Czechoslovakia, RC-135 aircraft flew round-the-clock missions monitoring Warsaw Pact communication networks, providing NATO commands with detailed intelligence on Soviet troop movements, command structures, and operational plans as the invasion unfolded. The intelligence gathered by RC-135 missions had direct, measurable impacts on American and NATO military strategy throughout the Cold War. Signals intelligence derived from intercepted Soviet communications informed NATO force posture decisions, shaped arms control negotiations, and provided early warning of potential military confrontations. When American negotiators sat down with Soviet counterparts to discuss strategic arms limitation treaties, they did so with detailed knowledge of Soviet missile deployment patterns, nuclear command and control procedures, and strategic bomber readiness levels, all derived in significant part from signals intelligence collected by RC-135 aircraft and supporting ground stations. NATO military planners used intelligence from intercepted Soviet communications to develop defensive strategies, allocate forces, and identify vulnerabilities in Warsaw Pact military structures. The intelligence advantage provided by comprehensive signals intelligence collection allowed the United States to maintain effective deterrence with fewer forces than might otherwise have been required, because American commanders could base their planning on concrete knowledge of Soviet capabilities and intentions rather than worst-case assumptions. This intelligence advantage was, in many respects, more valuable than technological superiority in weapon systems, because it provided the situational awareness necessary to use those weapons effectively and to avoid strategic miscalculations that could lead to unintended escalation. Soviet awareness of American signals intelligence capabilities gradually increased throughout the 1970s and 1980s, driven by a combination of intelligence reporting, technical analysis of captured American equipment, and direct observation of NATO military operations that demonstrated detailed knowledge of Soviet activities. Soviet military intelligence agencies, particularly the GRU and KGB technical intelligence directorates, devoted considerable resources to understanding American signals intelligence methods, attempting to reverse-engineer captured reconnaissance equipment, and analyzing the operating patterns of RC-135 aircraft to determine what information they were collecting. Declassified Soviet intelligence reports from the post-Cold War period reveal that by the late 1970s, Soviet analysts had correctly identified the RC-135 Rivet joint as the primary American signals intelligence platform targeting Warsaw Pact communications, and had developed relatively accurate assessments of its technical capabilities. However, understanding that American intelligence agencies were intercepting Soviet communications was very different from being able to prevent it. The fundamental problem faced by Soviet communication security officers was that modern military operations required extensive radio communication, and any encryption system deployed across thousands of military units would inevitably have operational vulnerabilities that patient, well-resourced adversaries could exploit. The Soviet military experimented with various countermeasures, including increased use of landline communications, deployment of secure fiber optic networks, and implementation of stricter communication discipline. But none of these measures could fully compensate for the intelligence advantage that the United States had established through decades of sustained signals intelligence operations. The technical evolution of Soviet communication security systems during the 1970s and 1980s reflected an ongoing, ultimately unsuccessful effort to regain communication security against American signals intelligence. New generations of Soviet military radios incorporated frequency-hopping technology that rapidly changed transmission frequencies, making interception more difficult. Improved encryption systems used more complex algorithms and more frequent key changes to resist cryptanalysis. Soviet communication security protocols were revised to limit the amount of sensitive information transmitted via radio and to mandate shorter transmission times that reduced the opportunity for interception. However, each of these countermeasures was met with corresponding advances in American signals intelligence capabilities. NSA engineers developed receivers capable of tracking frequency-hopping signals. Cryptanalysts adapted their techniques to attack new Soviet encryption algorithms, and RC-135 aircraft were equipped with increasingly sophisticated direction-finding systems that could locate transmitters even during brief burst transmissions. The technological competition between Soviet communication security and American signals intelligence capabilities continued throughout the Cold War, with neither side achieving a definitive permanent advantage, but with the United States consistently maintaining sufficient access to Soviet communications to support strategic intelligence requirements. This persistent intelligence access had profound strategic consequences. Soviet military planners were forced to operate under the assumption that NATO forces might have advanced knowledge of their operational plans, which constrained Soviet options during crises and increased the risk that military actions would be detected and countered before they achieved their objectives. The psychological and institutional impact of communication insecurity on Soviet military culture was significant and long-lasting. Once Soviet commanders understood that their radio communications might be intercepted and decrypted by Western intelligence, a culture of suspicion and operational caution developed that affected everything from tactical training to strategic planning. Soviet military exercises began to emphasize communication discipline, with units penalized for unnecessary radio transmissions and rewarded for maintaining radio silence during operations. Soviet military doctrine increasingly stressed the importance of deception, operational security, and compartmentalization, assuming that adversaries would have access to at least some intelligence about Soviet activities and planning accordingly. This defensive mindset, while prudent from a security perspective, also introduced operational inefficiencies. Excessive communication restrictions could slow decision-making, limit coordination between units, and reduce the flexibility necessary for effective combined arms operations. Declassified post-Cold War interviews with former Soviet military officers reveal frustration with communication security restrictions that they believed hampered operational effectiveness, with some officers privately questioning whether the cure of strict communication security protocols was worse than the disease of potential intelligence leakage. This tension between operational effectiveness and security was never fully resolved during the Cold War, and Soviet military forces entered the final decade of the USSR's existence still struggling to balance the need for rapid, flexible communication against the knowledge that Western intelligence agencies were monitoring their every transmission. The RC-135 Rivet joint program's success during the Cold War established signals intelligence as a critical, perhaps decisive domain of modern warfare, with implications that extend far beyond the specific context of US-Soviet competition. The strategic lesson demonstrated by the Rivet joint operations was that communication security is not merely a technical problem, but a comprehensive challenge requiring coordination of technology, training, operational discipline, and institutional culture. Even sophisticated encryption systems can be compromised if operators make mistakes, if protocols are not strictly followed, or if adversaries possess sufficient technical sophistication and operational persistence to exploit subtle vulnerabilities. The United States sustained investment in signals intelligence capabilities, including dedicated reconnaissance aircraft, ground-based interception networks, advanced cryptanalysis centers, and highly trained intelligence personnel, created a strategic advantage that could not be quickly replicated or easily countered. Soviet attempts to improve communication security during the 1970s and 1980s, while partially successful, came too late and were too limited in scope to fundamentally alter the intelligence balance. By the time the Cold War ended with the collapse of the Soviet Union in 1991, American signals intelligence agencies had accumulated more than 40 years of comprehensive intelligence on Soviet military communications, creating an institutional knowledge base that informed assessments of Russian military capabilities well into the post-Soviet era. The operational legacy of Cold War RC-135 missions continues to shape contemporary military intelligence operations. Modern variants of the RC-135 aircraft, equipped with digital receivers, satellite communication systems, and advanced automated signal processing capabilities, remain in active service with the United States Air Force and Royal Air Force, flying missions against contemporary adversaries including Russia, China, North Korea, and Iran. The fundamental mission has not changed. These aircraft still fly along the borders of adversary states, intercepting communications, monitoring radar systems, and collecting signals intelligence that informs strategic decision-making at the highest levels of government. Contemporary adversaries, aware of these intelligence collection efforts, have developed increasingly sophisticated communication security measures, including encryption systems based on quantum-resistant algorithms, extensive use of fiber optic networks that cannot be intercepted remotely, and operational protocols designed to minimize electronic emissions. Yet the strategic dynamic established during the Cold War persists. Nations that can maintain secure communications while penetrating adversary networks possess a decisive intelligence advantage, and the ongoing technological competition between communication security and signals intelligence capabilities continues to shape military planning and strategic competition. The Soviet commanders who believed their communications were secure in the 1960s and 1970s learned a costly lesson that contemporary military leaders ignore at their peril. In the electromagnetic domain, confidence in security must be continuously validated through rigorous testing, persistent vigilance, and the assumption that sophisticated adversaries are constantly working to exploit any vulnerability they can find. The RC-135 Rivet joint proved that even the most confident assessments of communication security can be dangerously wrong, and that in modern warfare, the side that truly controls information, who can see without being seen, listen without being heard, possesses an advantage that can determine victory or defeat before conventional forces ever engage.